2.4 notes, complex numbers, page 3. One of the nice things about I and powers of I is that they can typically be reduced into something simpler. So we are going to take a look at the patterns here when we talk about I's and powers of I's. So I is I, pretty straightforward from the definition on page 1. Remember that I squared is -1. I to the third, then, I can factor as I squared times I, which gives me a -1 times I. So I to the third is -I. I to the fourth, we can go ahead and factor. We get I squared times I squared, -1 times -1, which gives us a +1. Moving on from there, I to the fifth, I could write as I to the fourth times I, 1 times I to the fifth just equals I, and we are back at the beginning over here. Okay. So anytime we can factor out a power of 4, then that's just going to equal 1. And we can work with radically reduced powers on I. So let's take a look at A. I'm going to start by seeing how many times 4 will go into 37. Okay. And so I know 4 goes into 36. So I'm going to rewrite this as I to the 36 times I to the first. Let me back up and add in an extra step there. I to the 36 plus 1, which is I to the 37. That's an I to the 36 times I. I to the 36 is I to the 4th to the 9th. 1 times I gives us I. I to the 58th. So 4 goes into 56 evenly. So this becomes I to the 56 times I squared. I to the 4, if we just need the reminder, to the 14th. I squared is -1. 1 to the 14th times -1 gives us a -1. I to the 75th. 4 goes into 72 evenly. First part is 1. 1 times I to the third. I to the third we know is -I. I to the 80, 4 goes in evenly. Again, I to the fourth is 1. 1 to any power is just 1. One of the nicest things about working with complex numbers, and one of the most important points, is this conjugate. Conjugate of a complex number, a plus bi, is a minus bi, and we call those two pairs complex conjugate, those two binomials. Something special happens when we multiply a complex number times its conjugate, so let's use the FOIL method and figure that out here. 5 times 5 gives us a 25. 5 times -7i is -35i. Positive 7i times 5 is positive 35i. I've got positive 7i times -7i. I get -49i squared. These two are going to cancel out. That's that whole difference of two squares property. I end up with 25 minus -49. 25 plus 49. Which gives us a 74. Notice when we multiply a complex number by its conjugate, we get something completely real. Same thing here when we're dealing with just the imaginary parts. I get a -64 I squared. -64 times -1 gives us a +64. we are going to use conjugates to divide complex numbers. We really always want to write our complex numbers in that a plus bi form. Can't really do when we have real and imaginary in both the numerator and denominator. So here's what we're going to do. Here's our 2 minus 5i. We're dividing by 1 minus 6i. I want my denominator to be completely real. So we are going to go ahead and multiply by the conjugate of the denominator. So let's make a note. Multiply by conjugate of the denominator. And so I get 2 times 1, which is 2, plus 12i, minus 5i, minus 30i squared. 1 times 1 is 1, plus 6i, minus 6i. Those are going to cancel, minus 36i squared. Let's combine like terms. I got minus 30 times negative 1, which is going to give me a plus 30 plus 2, so 32 plus 7i over 1 plus 36, 37. And because we want this in a plus bi form, we've got to separate this into a real part and an imaginary part. We get 32 over 37 plus 7 over 37i. Or 7i over 37, both works. Real part, imaginary part. And there we go. So let's do this one more time. If you'd like to practice this, this would be a great time to pause the recording, take a shot at this, then unpause and come back and compare. And so we are taking 3 plus 4i. We are dividing by 3 minus 4i. I want to multiply by its conjugate, the conjugate of the denominator, because I want that real number in the denominator. I get 9 plus 12i plus 12i plus 16i squared, all over 9 minus 16i squared. In the numerator, 9 plus negative 16 gives me a negative 7. 12i plus 12i gives us a 24i. Over 9 plus 16 is 25. I get negative 7 over 25. There is my real part. I get 24 over 25i. There is my imaginary part.